Oh, hi team. Thanks so much for showing up for your learning. It's Tutor Grant, and we are looking at the 2024 Pascal contest, the one that we wrote in Mastery League this past Saturday. So let's take a look at some of the questions that people had questions about, either during the test or after. Or I looked and I saw many people got these questions wrong, so I'll show you some solutions. All right. In this question here, question 10, we are defining a new operation triangle. So a triangle B is the same thing as take 4 times the first number and add it to the second number. Okay? This is tricky because we have to do triangle twice. Double triangle. Okay, so here's how we would do it. Of course, we do the stuff in the bracket first. So I'm just going to copy out our expression, 5 triangle 2 in brackets triangle 2 again. Okay, so let's do 5 triangle 2. So that is equal to 4 times 5 plus 2. Okay, and then we're still going to triangle 2 that. All right, 4 times 5 plus 2 happens to be 22. And then we are 22 triangle 2. So that is the same thing as saying 4 times 22 plus 2. And 4 times 22 is 88 plus 2 equals 90. That's how you do these weird questions where they invent new operations, is you follow the instructions carefully and play their game. Okay, it's fun. It's fun to do new operations, so we're happy that they do that. Okay, question 15 was asked about. It's one of these geometry questions. It's very cool. Oh, look at that. We got ourselves an equilateral triangle, 60, 60, 60. Okay, that makes this one 120 because 120 plus 60 is 180. If that's 120, well, this here is also an equilateral triangle. I don't know that, and I don't know that, but I do know that they're the same. So triangle ADC looks something like x, 120. And so that means 120 plus 2x equals 180. Take away 120 from both sides, please. 2x equals 60. X equals, divide both sides by 2, 30. And that's what we've been asked to find, right? Angle ABC. ABC. Oh, darn, I found the wrong angle. But turns out that the whole thing's symmetrical. That's X anyway, so it's 30. So that's how you would find it, okay? This one here is 120. Both of these are X and X. And you solve for X. All right, let's go. Okay, this one, people did ask during the contest, and they asked interesting questions. Like, mainly the question was, is average speed average over time or average over distance? Was the question. And honestly, when I look at these questions before I kind of think about them thoroughly, I ask myself the same questions. Wait, if she spent more time driving at a slower speed, wouldn't that weight that speed heavier? But here's the formula for speed. Okay, average speed is equal to distance over time. Do not overcomplicate. Okay, don't overcomplicate things. Okay, so we're going to have distance divided by time. So let's see if we can find that. Okay, distance that she travels. Well, she traveled for 100 kilometers an hour for 2 hours. So her distance is 200. 2 times 100. And then the next 200, okay, so we're told distance, all right? Basically, we're told that distance is 400 kilometers total. Let's see if we can figure out time. Okay, we have time here is equal to 2 hours. 2 plus the next 200 kilometers, she traveled at 80 kilometers an hour. I wonder how long that took her. That took her 200 divided by 80 equals 20 on 8, 10 on 4, 5 on 2, 5 on 2 hours. 2.5. 2 plus 2.5. Okay? So here we have speed is equal to 400 divided by 4.5. And we had a calculator for this test, We don't need one here. This is how I would do this without a calculator, okay? I only really use a calculator for questions 20 and 24 on this test. So I multiply everything by 2 so that I get rid of that ugly fraction. Speed was equal to 800 divided by 9, and that's equal to, I just happen to know 8 on 9 times 100. I want a decimal, and so 8 on 9 is 0.888, all repeating, multiplied by 100, which is the same thing as 88.888 da 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 da. So it's equal by rounding to 89. And of course it's 89. Of course they make the answer 89. Have you not noticed yet that the answers in these, it's the only Fibonacci number here, okay? Not Fibonacci, not Fibonacci, not Fibonacci, not Fibonacci. Fibonacci! Math people love Fibonacci numbers to an unreasonable degree. So if you see a Fibonacci number in a multiple choice and you aren't sure about the question, just choose a Fibonacci number. Actually, this is good advice. Some of the best advice I've ever given you. Let's go. Let's keep going. I was very interested in question 20 because I struggled with question 20. I peeked at the solutions and learned something. Okay, so here, I might not have perfect scored this quiz because I think I thought it was 63, but it's not. Okay. Also, a quick scan. There's no Fibonacci number here, so too bad, so sad. Okay, if there was, then we could use that. 67 is prime, and it happens to be the only prime number here. So that might aim us towards that. 1967 is also the last year that the Toronto Maple Leafs ever won the Stanley Cup. And that's another clue because this quiz was created by probably Leafs fans, just based on where this quiz was created in the world. That's a lot of trivia that you don't need. Okay, so here's what we're looking for. We're looking for some number between 1 million and 10 million that when we multiply it by 25, we get a number with a very large digit sum. Okay, so we're between 1 million and 10 million. Here's the trick. When we multiply this by 25, we'll get a number. It's definitely between 25 million and 250 million. Okay? And if we multiply some number n by 25, it's going to be dot, 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 some digits in the front, pretty much any digits we can get, except the last two digits will be 00, 0, 25, 50, or 75. Okay, those are our only options for last two digits. And we want those because they have a digit sum 12. And this is the next closest. 25 is digit sum 7, which is smaller. Okay, so we're going to look for the number that has the biggest digit sum in between there. And that number is 199,999,975. And that's the biggest digit sum we can get. Okay, 1 plus 6 times 9 plus 7 plus 5 happens to be 67. What did I tell you? Leaf fans. All right, so that's how I would approach this question in the future, having looked at the solution. I like to look at the solutions and I see like, oh, that's the way. And then I stop reading the solution and I do it myself. So that's why it seems like I really know what I'm talking about here. Okay, 24. Now we got some doing to do, okay? You do these types of contests and you get to like questions 23, 24, 25. I hope you saved a lot of time because these questions are tricky. Okay, so I'm just going to translate the information from there onto our diagram. CD is 30. Okay, CE is 30, but that's the F is the midpoint, so that's 15, 15. And we are looking for the value of y minus x, okay? We want like the positive difference between x and y, but y certainly looks bigger than x, and the diagram looks pretty darn good. So I'm pretty sure we're looking for y minus x, not x minus y. So what can we do? Well, finding the area of that weird kooky badonk is tricky. I agree, it's tricky. Okay, so let's see what we can do. All right, so I've solved this problem in the past. I haven't looked at it recently, so you're going to see me kind of working through it fresh, but for the second time. Okay, so here's something I know. Okay, this point here, and I want to create a line going to C. All right, that's also length 30 because it's the radii of the circle. So I can move the radii and it's going to be 30 everywhere. The neat thing is, because if I went this way here, okay, that's also 30, but I haven't really proven it yet. The reason that it is, because that's not a radii of this circle, okay, but this is down here, also a radii. Because F is the midpoint, and this height here, we don't know what it is, but call it H. Okay, those two triangles share both sides, right? Like this is H over here, and that's H over there. This is 15, and that's 15. So since these triangles share two sides and a right angle, then they're congruent. They're just like a reflection of one another. Okay, therefore, this triangle equilateral, yo. Okay, that's 30 there as well. This is 30, 30, 30 on the side lengths. So that tells us this is 60 degrees. This is 30 degrees. This is 60 degrees if we ever need that. I don't think we ever need that. Okay, and that's important. All right. Why is that important? Well, it's important for these reasons. It allows us to calculate y and x, because now we can use circle sectors and find the area of different things that we're chopping out of other things. Okay, so we know we're looking for y and y minus x. Let's go ahead and calculate y first. So y, area y is equal to, okay, I'll do this, all this work in orange so that you'll see it clearly. 60 degrees of my circle, okay, is 1/6 of this circle, will be the whole circle, right? So 1/6 of a circle pi times 30 squared is the area of that whole pizza slice. But then I have to remove, okay, I'm going to remove this triangle because that's not part of y. And for that I need the height h. So I know what it is, but I'll show you how to calculate it. And then I'm going to also remove this here. And if I subtract those two things, I think you'll agree that all I'm left with is that weird little region y. So I'm going to call this A1 and this A2. Okay? And so I have that minus A1 minus A2 will do it. Okay? So y is going to equal 1/6 times 30 squared, which is 900 on 6. 900 on 6 is 150 pi. Okay, that's just simplifying 30 squared times 1/6. Okay, minus, I need A1, so I'm going to show you A1. Here, H squared plus 15 squared equals 30 squared. Okay, so we need H, so we're going to find it this way. So H squared equals 900 minus 225, because we're going to subtract 15 squared, 225 from both sides. 900 minus 225, 675. So H squared equals 675. Let's take the square root of that. Okay, and we're going to work with this number 675. we notice that it's divisible by 25, and that gives us 25 into 600 is 24 or 27. 27. And 27 is 9 times 3. Why am I doing that? Because this here is a square. 9 times 25. 9 times 25 is 225. So this number is 225 times 3. Okay? So h is equal to the square root of 225, which is 15 squared, times 3. And so h is equal to 15 root 3. That's our simplified version of h. And when I said all fancy pants a little while ago that I already knew what it was and I would show you how to calculate it, it's because this is a special triangle and I have these memorized, okay? And you're going to memorize your special triangles too, just by being good at math and doing lots of math, okay? The ratio here, when you have 1 to 2, this is root 3. So I knew that would be 15 times root 3, okay? All right. So that is to say that A1, remember I told you we'd have some doing with this question, especially with me talking about it. Okay, A1 is going to be base, which is 15 multiplied by height, which is 15 root 3, all divided by 2. Okay, that's A1. And A2 is going to be 1/4 of a circle with a radius 15. 1/4 times 15 squared pi. Okay, let's keep going. Okay, y is equal to 150 pi, but I see that that wants to be on a base of 4. Okay, I want a common denominator 4. So I'm going to say 600 on 4. I don't know why my pi looks so weird there. There's a less weird pi. Minus 225 pi on 4, that's taking away a2, and then take away 225 root 3 on 2. Y is equal to, in the final analysis, 375 pi on 4 minus, do you want to put that all on 4? You can. I would probably just keep it this way for now. 225 root 3 on 2. It's highly irrational. Okay, we're mixing up the square root of 3 and pi. So get your calculators out. This was, to find the closest integer, like, gosh, I don't want to calculate that by hand. I use calculator every day. It's not even fun as like a fun exercise, but that's y, and that's a simplified exact value for y. We're gonna decimal approximate later. Now let's do x. Okay, so I'll do x in purple. Okay, because we need more purple in this game. Okay, so I'm noticing that if I do the area of GDFC, so I want x, okay? X is equal to area of GDCF, okay, area of the big rectangle minus the circle sector, so I'm going to call this A3, okay, minus A3 minus A1. Okay, I've already calculated A1, so I might as well use that. And that will give me x. X is equal to 15 times 30. He says, asking someone else to give him the answer. 450. Okay, that's the area of the big rectangle. Minus A3. A3 is 1/12 of the whole circle because it's only 30 degrees of the circle. So something I didn't show last time was 30 degrees over 360 gives us 1/12 of the whole circle. So the circle sector A3 is 1/12 the whole circle. That's how you find the area of a pizza slice. If you want to get real technical about how much you owe on pizza night, you just find the area of all the pizza you eat and tell your friends, and I'm sure they're going to be very interested to know. And they're going to say, how many decimal places of pi did you use? Maybe your friends wouldn't say that, but mine might. No, I don't have any friends that would. Okay, anyway, I don't have any friends. I have lots of friends. I'm just kidding. Okay, carry on. Hurry up. Stop making jokes. Pi r squared. So r is 30. And we're going to square that. And we multiply by pi. That's a3 minus a1. A1 is 225 root 3 on 2. Okay, 90 on 12. That simplifies right down, doesn't it? 12 times what is 900? 900 on 12 indeed goes. Okay, so let's see. 900 on 12. Gosh, I'm just going to long divide here. That's 85? No, 75? I think it's 75. Right? Right? No. What is it? Why can't I do this? Just do it this way. 900 divided by 2 is 450. Divide by 2 is 225, that old number. Divide by 3, and now we have taken out our 12, is 75. Why didn't I not believe myself that it was 75? That's pretty weird. Okay, so that is to say, we have x is equal to 450 minus 75 pi minus 225 root 3 on 2. That's our simplified value for x. Now, we want to calculate y is equal to y minus x. Sorry. Y minus x equals, I like writing out the thing I'm going to punch in my calculator because I'm old school. Okay, I like doing as much by hand as possible and then reaching for my calculator. Notice that these are going to cancel out, so we don't need to type them on our calculator. And then we're going to be minus x, so minus 450 minus 75 pi minus 225 root 3 on 2. That was exciting. I didn't know if I was going to get it in there. There's my end bracket. Oh dear. Okay, so I'm just going to pion that, okay, because those are going to cancel, because minus a minus is a plus. Now we get out our calculator. That's why I've had it open this whole time, was for this very moment. Okay, so I'm going to clear everything out. 375 divided by 4 equals that, times pi equals that, minus 450 equals that, plus 75 times pi equals, I happen to know that's the right answer, 80.143, and we were asked for the closest integer. That's how this one done. 80 is your final answer. Approximately equal to 80. Let's do, this is y minus x is equal by rounding to 80. There. Dun, 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 dun. All right, so that one, it's some doing. It doesn't require a lot of flashes of insight. It's not like a real like problem-y type problem where it's like, how am I even going to get started? You get started by finding the areas and expressing them. And the real like one trick is noticing that you have here a 60-degree triangle. If you don't get this, then you're stuck. I don't know how you do it without that. I think you're stuck. So you need that insight in the beginning, and then you're just comfy working with circle sectors and seeing like, ooh, I want an expression for that. So that's the whole rectangle minus that bit minus that bit. I can find a formula for that bit and that bit, no problem. And then you do it. And then you be tidy. And if you're tidy, you'll get it. Okay, and if you're not talking about it while you're going, then it's even faster. Okay, this one's fun. I really like this problem. Okay, 25. Okay, nobody got this problem except me. I got it yesterday, but I missed 20. I missed number 20, and I never got the lockbox one. I haven't solved the lockbox question yet, so I'm not like trying to be over here saying I perfect scored this test or nothing. This is also my like third time seeing this test. So let's go. All right. We are interested in triples of A, B, C, where A, B, and C are numbers from this list. The numbers are 3, 9, 27, 81, 243, and who can care less. Okay, the next three, I just don't happen to have them memorized. 729, don't forget. Okay, you don't need to evaluate them. You don't need your calculator here because this arithmetic is real simple. I'm going to show you the arithmetic tricks. So we want the total number of triples where A is less than or equal to B is less than or equal to C. Okay, so C is strictly largest, but can be the same size as B and A. Okay, and we want AB divided by C, AC divided by B, and BC divided by A to all be integers. Okay, to all be integers. Well, to be honest, these two are always integers. It's only this one that could ever not be an integer, AB on C. The reason is, let's evaluate some of these. I'll do some really extreme ones, like let's let A be 3 to the 1, B be 3 to the 2, and C be 3 to the 8. Okay, and if we look at them, BC on A is an integer because that's 3 squared times 3 to the 8 times divided by 3 to the 1. Which is, let's use expanded form here. Here's 3 squared, 3 times 3. Here's 3 to the 8, 3 times 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 3. Oh, I was worried I wasn't going to get there in the end. All divided by 3. Okay. Here's how the arithmetic works. I have 10 copies of 3 upstairs being divided by 1 copy of 3 downstairs. Which at the end of the day, this will cancel, that will cancel, and I'll get 3 to the 9. So another way of working on these problems is just use your exponent laws, which this problem is testing you on. If you have your exponent laws, you'll realize something interesting about these 3 expressions here. Okay, so BC on A, 3 to the 2 times 3 to the 8 is equal to 3 to the 2 plus 8. When you're multiplying powers of the same base, you add the exponents divided by 3 to the 1. So that would be 3 to the 10 divided by 3 to the 1, which is equal to the same thing I wrote there, which is equal to the 3 to the 10 minus 1. When you are dividing exponents of the same base, you subtract the exponents because you have these cancellations here. And you're adding 2 copies of 3 to 8 copies of 3. You're not adding them. You're multiplying that many more. So you add that number of copies. Okay, that's why multiplication looks like addition in these cases. So if C is bigger than the others, there'll always be enough juice up there, enough copies of 3 to totally cancel out whatever's below. This is the only one where A times B divided by C might be a not integer, okay? And I'll show you when, like here, this case here, these won't be an integer, watch. A times B divided by C equals 3 to the 1 times 3 to the 2 divided by 3 to the 8. Uh-oh, we got way more copies downstairs than upstairs. Okay, so that's going to be 3 to the 3, 1 plus 2 divided by 3 to the 8. That's going to be 3 to the negative 5. What do I do with 3 to the negative 5? That's the same thing as 1 over 3 to the 5. Okay, that's equal to 1 243rd. That's not an integer, is it? That's a rational number. So, the realization here to make progress. Oh, and like maybe I should talk about that a little bit. All right, fine. 3 to the 3 divided by 3 to the 8 is equal to 3 times 3 times 3 divided by 3 times 3 times 3 times, I'm bored, I don't want to write the other 5. Cancels, cancels. See where the 3 to the 5 ends up? 1 over 3 to the 5. A negative exponent just means, hey, 3, take your stuff and go move downstairs. Okay? A negative in the exponent is just a bossy landlord telling you to take all your stuff and move. Okay, all right, let's go. So, need some space here. Here are our numbers. 3 to the 1, 3 to the 2, 3 to the 3, ... 3 to the 8. Okay? If, it's a very strange if a plus b, well, I should say the exponents of a plus b, oh wait, if a times b is greater than or equal to c, then AB on C is an integer. That means if the exponents add to the same thing as C, then that's an integer. I've already talked about why this one and that one are always integers, because C is necessarily biggest. So we can disregard those. We don't need to consider them. Okay? And we're looking for the total number of triples, A, B, C, where A is less than or equal to B is less than or equal to C. So here's how we will start finding those. Okay, let's go case by case and look at different cases. Okay, and actually I looked at all the cases, and I don't really have a great shortcut for counting them, but I'm pretty sure I can build a shortcut, but I'm not going to. Okay, there's not that many. C is equal to 3 to the 8. Then let's make a little table. Okay, here's B and A and the total number of ways that we can do this. Okay, and this is what we're going to be counting. So if C is equal to 3 to the 8, then B could be 8. I'm going to just write down 8, not 3 to the 8. Okay, and A could be 8 to 1. 8, 7, 6, 5, 4, 3, 2, or 1. So that is to say there are 8 different triples when C is 8 and B is 8. And I'm not going to list them all, but there are 8 of them. Okay? If B is 7, then A could be 7 to 1. Okay? A can't be smaller than B, but it could still be as small as 1, like 3 to the 1, because 7 plus 1 still adds to 8. So there's 7 of those there. If B is 6, A could be 6 to 2. A cannot be 1 because 6 plus 1 is 7, and then you would have 3 to the 6 times 3 to the 1 divided by 3 to the 8, and that's equal to 1/3. 1 over 3 to the 1. So that's not an integer. So this has to at least be 2 if B is 6. Okay, so there are 5 ways of doing that. If B is 5, then A could be 5 to 3. That is 3 ways. And if B is 4, then A has to be 4 and only 4, and there's only 1 way. So the shortcut would be to notice that these always go down by 2 each time, and that this one is whatever B is. There's 8 of them. So then we add those up. 1 plus 3 plus 5 plus 7 plus 8 is 24. So we have 24 total triples when B is 8. And sorry, when C is 8. Okay, now let's look at C equaling 3 to the 7. Okay, so B could be 7. A would then have to be 7 through 1, and there are 7 ways to do that. If B is 6, A can be 6 through 1, and there's 6 ways of doing that. If B is 5, then A can be 5 through 2, and there are 4 ways. And if B is 4, then A is 4 or 3, and B can't be 3 because then A would be 3, and 3 plus 3 is 6 and not 7. So there are 2 ways of doing that. So their total, we have 19. If C is 3 to the 5, okay, maybe some of you are already like, I see it now, you don't have to keep doing this. You're going to B is 5, and there's 5 to 1 for A, and then the total number of ways that we can do that there are 5. If B is 4, then this is 4 to 1, and there are 4. I missed 6. Okay, well, I'll count it next. Okay, 3 to 2, and then that's the smallest, so that's 2 there. So those were 11. Okay, when C is 3 to the 5. C equals 3 to the 6. Okay, B, A, 6 to 1. There's 6 of them. 5 to 1. There's 5 of them, and then 3, and then 1. I'm going to start using just that simple shortcut. 1 plus 3 plus 5 plus 6 is 15, right? 15, cool. Okay. If C equals 4, 3 to the 4, then B and A have this thing going on. B could be 4, A is there's 4 of those. B could be 3, A could be 3 to 1, there's 3. And if B is 2, A is 2, there's 1. So that adds together to make 8. Okay, I've been putting boxes around them. So I just want to make sure I count all my boxes because I put circles up there. Okay, C is 3 to the 3. C is getting pretty small, so our options for B and A to keep them smaller are getting less and less. So B could be 3 and A could be 3 to 1. There's 3 ways. And B could be 2 and A could be 2 to 1, and that's it. So there's 2, so that gives us 5. C equals 3 to the 2. B could be 2. A could be 2 to 1. There's 2 ways. If B is 1, A is 1, and there's only 1 way, so that's 3. And if C is the smallest one, 3 to the 1, then it always works, but B has to be 1, and A has to be 1. And there's only 1 way, so 1. Okay? Now, all that's left is to add up all the cases. 24 plus 19 plus 15 plus 11 plus 8. Nine, 17, 28, 43, 62, 86. 86 different triples can be taken from this list of numbers, which would guarantee that 2 of them multiplying, dividing by another one, always gives you an integer. 86 triples. Cool. Let's see if I'm right. Let's see if I'm right, everybody. I happen to have the answers open over here. 86. Yeah. Oh, they did something different. Oh, they created like little R and S and T notations for the exponents. How formal of them. I did not do that. This was a just give me the right answer type test, so I wasn't that formal. Okay, so I hope that all of that was appealing to you and helpful to you, and that you were able to follow along and get some good learning done. Any questions? Hit me up in the community. Bye for now, everybody.